Hello learners, welcome back to my channel Shraddha's Physics. In this lecture we will continue the depolarization field and then we will see the dielectric susceptibility. So let us start with our topic depolarization field. If the polarization is uniform within the body, the only contribution to the macroscopic field are from E0 and E1. And what are these E0 and E1? So the resultant field we can write the total electric field E will be equal to E0 plus E1, where E0 is the field applied and E1 is the field due to the uniform polarization, and that is called the depolarization field. So in case of a dielectric material, suppose it may be in your polar molecule or your non-polar molecules. So when you apply some external field, that is suppose E0, then the charge that lies inside this dielectric material, the positive charge will get in the direction of the field, and the negative charges they will get separated and lies in this place. Or this is basically the surface charge. So we can write these charges, we can place like somehow in this way, okay, and these are suppose your negative charges. Hence the polarization occurs, or we can say that now the induced electric field that develop, it will be just in the opposite direction to this E0. Okay, now this electric field is called, this is your E1, and that is called the depolarization field. Okay, so here you can see the electric field that you have applied in the direction of this, that is your E0, you have applied in this direction. Now because of the polarization, the field developed, that is in the black color, so it is in the opposite direction to that of the applied field, and that is called the depolarization field, that is your E1. So this E1 tends to oppose the field E0. Since it is in the opposite direction, we can say E1 tends to oppose the field E0. So the depolarization field, we can say the depolarization field, it occurs due to the polarization charges on the external surfaces. Okay, so the depolarization field occurs, you can see here, this depolarization field occurs due to the polarization charges on the external surfaces. Hence it depends on the geometrical shape of the dielectrics. Okay, I will discuss it in the brief, that is how it will depend on the geometrical shape. So here the depolarization field also, it depends on the geometrical shape of the dielectrics. The specimen in the shape of the ellipsoid, that is a class that includes sphere, cylinder, disc as the limiting forms, have an advantageous properties, that is a uniform polarization produces a uniform depolarization field inside the body. Okay, so it basically the depolarization, it will depend on the shape of the specimen, we can say. And also you should remember that a uniform polarization field, it will produces a uniform depolarization field inside the body. If we will consider Px, Py and Pz, these are the components of the polarization along the x, y and z axis. They refer to the principal axis of an ellipsoid. Then the components of the depolarization field we can write in CGS. In CGS system, the electric field along the x-axis we can write E1x. The component are E1x will be equal to minus nxpx, and E1y will be equal to minus nypy, and E1z will be equal to minus nz and pj. Okay, and similarly in SI unit, you can write this E1x will be equal to, simply you have to divide epsilon naught here. So this will be minus nxpx divided by epsilon naught, and E1y will be equal to minus nypy divided by epsilon naught, and E1z will be equal to minus nzpj divided by epsilon naught. So these are the polarization field occurs because of the polarization field. And here this nx, ny, nz, these are called the depolarization factors. So these nx, ny, nz are the depolarization factors, and its value depends on the ratio of the principal axis of the ellipsoid. Okay, and these n values are positive. If you take the summation of this nx, ny and nz, you will get the value will be 4 pi in CGS system, and this nx plus ny plus nz will be equal to 1 in case of SI system. Now we will see how this depolarization factor depends on the shape. That is, the first of all, if you consider the spherical shape, that is a sphere, then you can choose any axis. Then the n factor value in CGS system will be equal to 4 pi by 3, and in SI the n value will be equal to 1 by 3. And in case of the thin slab, if you choose the axis is normal, if you choose the normal axis, that is your perpendicular axis, if you choose, then the factor n will be equal to 4 pi in CGS, and the n factor will be equal to 1 in SI system. Okay, but this thin slab, if you consider the axis in a plane, then the CGS as well as in SI, the n factor values are 0. Okay. And similarly for the long circular cylinder, if you consider the longitudinal axis, then the factor in CGS system n factor equal to 0, and in SI system also this n factor equal to 0. Okay. But if you choose this long circular cylinder, but in the transverse axis, here you have considered in longitudinal axis, but if you consider the transverse axis, then the n factor in the CGS system will be 2 pi, and this n factor in SI system, it will be equal to 1 by 2. So you can see here, if you change the axis, if you consider the different axis, also this n factor will changes. And also for the different shape, the n factors are different. So the depolarization field, it can be reduced to 0 in two ways. Either by working parallel to the axis of a long fine specimen, or by making an electrical connection between the electrodes deposited on the opposite surfaces of a thin slab. So these are the two ways by which you can reduce the depolarization field. Now you can see here, if you consider, this is your this is in the form of your ellipsoid structure. So the depolarization field here, the depolarization field E1 is just opposite to the P. Okay, so here the electric field E1, and this is your the P, the polarization. So the surface charges, that is the facetious surface charges, you can say, they are indicated, the field of these charges is E1 within this ellipsoid. That is, in this case, if you apply the field in this direction, if you will apply the field, this applied field is your suppose E0, then what will happen? The positive charges, they will accumulate at this point, that is on the surface of the ellipsoid, in this way. Okay, and that is in the direction of the electric field. And also the negative charges, they will accumulate at this point, at this part. Okay, so because of this positive charge and negative charge, they will again produces an electric field, that is in this direction. In this direction they will produce an electric field, that is your E1. And now this electric field E1, they will try to oppose this electric field E0. Okay, so here this E1, this is called the depolarization field. So a uniform applied field E0, it will induce uniform polarization in an ellipsoid. So in SI system you can write P will be equal to epsilon chi E, and this is your, in CGS P will be equal to simply chi into E. This chi, this symbol chi, this represents the dielectric susceptibility. Okay, this represents the dielectric susceptibility, and in SI system this chi SI I can write, this is your in SI, that is your chi SI will be equal to 4 pi times chi CGS. Okay, this is your important point. The susceptibility in SI system will be equal to 4 pi times the susceptibility in the CGS system. Again, if E0 is the uniform and parallel to a principal axis of the ellipsoid, then in CGS system E will be equal to, the resultant field will be equal to E0 plus E1. This E0 is the applied field and E1 is the depolarization field. So now you can write this E0 will be, this is your E0, and in place of E1 I can write this will be your minus NP. From this relation, that is when we are calculating the components, you can see here this E equal to, combinedly I can write E will be equal to minus NP. Okay, hence we can say that in SI system also E will be equal to E0 minus, simply you have to divide, E will be equal to NP divided by epsilon naught. You can also see here This in SI system, this E equal to, if I will consider this as a whole, E will be equal to minus NP by epsilon naught. So finally, we can write the resultant field will be equal to, you can see here, the resultant field E will be equal to E naught plus E1. Okay. In CGS system, this E will be equal to E naught minus NP. But in SI system, this E will be equal to E naught minus NP divided by epsilon naught. Now again, if you will see, in CGS system, this P, that is the polarization, equal to chi into E naught minus NP, because you know P equal to chi E. You know the relation P equal to chi into E. So in place of E, I can put E naught minus NP in case of your CGS system. And similarly, in case of SI system, in place of E, you can substitute epsilon naught E naught minus NP, because E is your epsilon naught E naught minus NP. Now, if we will take, first let us see for the CGS, then after we will go for the SI. So let us see first the CGS one. So this is your P, and here also the P term is present. So if I will take this chi into NP, this is your chi into minus NP term to the left hand side. Now this will be P whole into, for this term, this is 1 plus, for this term this will be, this negative sign becomes your positive sign, N into chi, so plus N into chi, that will be equal to chi into E naught. Okay. So this P will be equal to chi divided by 1 plus N into chi whole into E naught. Okay. So this is the polarization, that is, you can say the relation between the polarization and the electric field, that is the applied electric field in CGS system will be equal to P equal to chi divided by 1 plus N chi into E naught. Similarly, for the SI system, you can see here, if we will take this NP, that is your minus NP into chi term to the left hand side, then this will becomes again, this will be plus. If we will take common P, this will be, the first term will be 1 plus, this will be chi into N, this is a plus chi into N, that is equal to epsilon naught chi E naught, this term. Okay. So now this will be equal to, if we will write P, so this P will be equal to epsilon naught chi divided by this 1 plus chi N whole into your E naught. Okay. So this is the relation between the polarization and the electric field in case of the SI system. Okay. So the value of the polarization, it depends on the depolarization factor N, because the applied field is here E naught, but here the depolarization factor, it will depend on the geometrical shape, because this depolarization factor N, it will depend on the geometrical shape, that is the specimen we are considering. So here the value of the depolarization, it depends on the depolarization factor, that is N. So this is all about your depolarization field and the dielectric susceptibility. So this is all for today. If you have any doubt, can ask me in the comment section. Thank you all.